watch this. Right. We begin our chat. Okay. So today we're going to basically do a little bit review, and then next week we have a quiz. So the first we're going to looking at the rules of algebra. So we looked at before this. So I call this okay. Why this is so? Can I change that to okay? Oh, this one better. So we got the ground rule of algebra. So when we study the algebra, really just come down to is to understand the rules. So it really come down to we got addition and multiplication. So let's see how many rule we have. First one is called A plus B is equal to B plus A. And A times B is the same as B times A. So do you remember what is this rule? Yeah,
Trying to remember.
what's that?
I'm trying to remember.
That's fine.
Is it associative?
No, associative is when you're dealing with more than two. So this is called commutative.
Oh,
Then this is associative. When you have more than two, you can doesn't matter which side you start with. Or when you multiply, doesn't matter which two you do first. Now, sometimes one is better than the other. Like for example, if I say we got 2 plus 4 plus 3 plus 7 plus 6 plus 8, I can do 2 plus 4 plus 3, but I can just do 2 plus 8 is 10, 4 plus 6, 10, 3 plus 7 is 10. So I got 30. So I can get that pretty quickly. Okay, let's see, how do we erase that? Okay, let's see, do they have okay, so it's my first time doing this. So what's that? Oh, I guess this is just good pointing. Okay. All right, that's useful. So we got select 10. Okay, here's the eraser. Okay, let me go back. All right. And this is called associative. And then we have A plus 0 equal to 0, or A times 1 equal to A. Now remember what this rule is?
yeah, ask something because I'm trying to set my volume levels and I can hear anything.
Yeah, this is called identity. identity rule. That means when you add 0, does not change the value. When you multiply 1, does not change the value. So now we're going to this one, a plus negative a, that equal to 0, or a times 1 over a, which is reciprocal, that equals to 1. Now, do you remember what's this rule?
I don't remember.
This is called the inverse.
Yeah,
Good? Yeah. So
yeah.
fine, you don't remember because we're going to go over that many times when we're actually using it. Okay. Then this is equal to a times b plus a times c. Or you could go the other way around to the right, which gave you a times c plus b times c. Now, what's this rule?
Distributive.
Distributive. Very good. Distributive. So basically, we just distribute this one to every item, every term inside the parenthesis. Okay, so that's basically a grand rule of algebra in terms about addition and multiplication. Then we're going to looking at this properties for equality. Oh, properties of equality. Okay, so it's basically come down, we have this. If A is equal to B, so if you have the equation now, that's what we took equality, then we can add we can add the same thing on both sides. As long as we add same thing on both sides, then we're fine. So this is the called addition property. So this, when we have an equation, then adding the same thing on both sides does mean it's still true. So the equation is still true. And the next one is if A is equal to B, then A times C is equal to B times C. So this is called multiplication.
I can't see the screen.
You cannot see the screen?
No.
Huh. Are you sure?
Yeah.
Okay. Let's try different. Maybe try this one. Now, can you see the screen?
Yeah.
Okay. All right. So we talk about the properties of equality. That means if A is equal to B, then A plus C equals to B plus C. So this is called addition property. And also if A is equal to B, then A times C is equal to B times C. This is called multiplication property. Good?
Yeah.
So now we have 10 ground rules for algebra and 2 properties of equality. So with that, then we can solve linear equations. So for example, 3x plus 5 equal to 7. We know that we can add both sides the -5. Now, this is what we use. This is using the addition property. And the reason we add, well, the addition property is just basically, it doesn't matter what value, as long as you add exactly the same thing on both sides, then you are okay. But the reason we add -5 is what we want to cancel 5. So that is our inverse property. So we got 3x plus 0 equals to 2. Then 3x plus 0 should give 3x. And that's the identity property. Then we multiply reciprocal of 3. So a number times reciprocal is 1. That's the inverse property. Then we got 2/3, and 1 times x, we know is x. That's the identity property. So therefore, if we use, as long as we use those properties, then we can get the right answer. Good?
Yeah.
Okay. So I'm going to have you work on a couple of those problems, and you can just type that answer in the chat. Okay, let's see. 3x plus 5 equal to 12. Very good. Give you another one. 2x minus 7 equals to -3. Very good. Okay. So basically, once you use those properties, you can easily solve linear equations. And we also can use the same property to do other problems. But as long as we follow the same rule, we'll be fine. So for example, when we do, we know that speed is distance over time. So therefore, if we say we travel distance 120 miles in 2 hours, so therefore our speed is 120, which is distance, divide the time it takes to go over that distance. So we got 60 miles per hour. Good?
Yeah.
Okay. So that's actually pretty straightforward. So now we have, this actually is a definition. So in the old time, we just use this, a triangle from that. We actually can rewrite it to make things a little bit easier. Use S, the distance is D, and time is T. Now with that, well, we can also come up with formulas when we know the speed and we can figure out, well, first of all, knowing the speed and time, we can figure out the distance, because S, this is definition. So therefore, D over T is equal to S. We just flip that, which it should be the equal. That's properties, one of the properties of the equation. And then we just multiply T on both sides. So we're using the multiplication property of equality. And then this cancel. That's the inverse property. And we got D equals ST. So therefore, if we know the speed, we know the time, we can find the distance. So if we say the time is 3 hours, then this speed is 50 hours, 50 miles per hour. Then we just simply 50 times 3 is 150 miles. Yep, we good?
Yeah.
And we also can work out. So now we got a new formula. Is distance equals to speed times time. And then we're going to, now we have two formulas. Distance is speed times time. And then if we want to figure out how long it takes to go from one place to another, we know the distance, we know the speed, we figure out time. Well, we have this. We can either use this equation or use that equation, and not this equation. It's easier to use. So we know speed times time is equal to distance. So therefore, if we times 1 over s on both sides, then that cancel, we got t, and this side just d over s, which is the time is equal to distance over the speed. So if we say, okay, we know the distance is 150 miles, and we are driving at 50 miles per hour, and then our time will be 150 over 50. That gives us 3 hours. Okay, good.
Yeah.
I'll give you a couple things to work on. Okay, so now we know from A to B, and it is 160 miles, and we're driving at 60. This is miles. And driving at 60 miles per hour. Now, what is our time? All right, so let's see what we got here, right? is 160 over 60, that cancel. Now we got 8 over 3, right? Very good. So 8 over 3, we got 2, 6, 20, and you got 6, 6, 6, 6, 6. So when we had run into something like this, it's better just keep as a fraction without rounding, because we don't know where to round yet. And this makes a huge difference if you are doing science or engineering, because the number of, to what accuracy is it really depends on the situation, what you are doing. Good.
Yeah.
Yeah, I have seen a lot of students doing that, just round it. So before you can run, always question like to what, to what digit, which digit. And if we don't tell you to which digit to run to, you just keep as the accurate answer. In this case, will be just a fraction. Okay, all right. So let's see if we want to do from point A to point B, and we drive at 50 miles per hour, and it take us 90 minutes. And so how long it will take us to go from point A to point B? Well, make sure the unit is, the unit is very important. Here, we're doing miles per hour, but this is a minute. So in order for us to multiply, we have to make sure the units are the same. So we have to convert this to 90 minutes to hours, which is 1.5 hours. And then the distance is 50 times 1.5. And that will give us it was 75 miles. Good, Eddie?
So in the minutes, you convert that to hours or something?
Yeah, you convert minutes into hours because because the units here is miles per hour, right?
Yeah,
Makes sense?
yeah.
Uh-huh. Yeah. Okay. All right. So, and there is other applications in real life is to dealing with when you're driving. It's how much gas you takes, and how long, I mean, with how many gallons of gas, and you can drive how long, things like that. Okay. Let's say you have what come down to is we have something called miles per gallon. That basically is how many miles you have driven, the distance, and how many gallons you burned. So that is a capacity. Okay. And we can change this one to R, which is called rate. Yeah. Like now there are all kinds of rates. Like we talk about speed is a kind of rate, or sometimes the price, like when you go to a store, you say like it's $7 per pound or $3 per pound. Those are also a kind of rate. So now we can write, well, we can use D for distance and G for how the gallons we take. So now we have this R equal to D over gallon. Now, based on that, we can work out if we know the rate, if we know the distance, we can figure out how many gallons that we need or how many gallons we'll run. Well, normally, like this is not a really big problem when you are driving. I mean, we have, stations all over the place. We shouldn't, normally we don't have time. But if you are actually flying an airplane, then you have to make sure you have enough gallon to get to the next airport that where you will land. So the pilots actually had to do this kind of calculations. Well, now if I know the rate and I know the distance, well, I can say I know our distance divided by gallon is equal to rate. Now, if I times gallon on both sides, now this side, the gallon will be canceled. So we get another equation is that the distance is the rate, how many miles per gallon, times gallon, give us how many miles. But from this, we got another new, this is the definition, how we started, then we get a new equation. And from that, we'll say, if I want to figure out how many gallons it will take, we know that R times G equal to D. Then we just times reciprocal of that, and that cancel. We got G, and this side we got D over R. So we got another equation. So that can help us to do, if we know two of those three quantities, we can figure out the other. So I'm going to rewrite down here. We got R, this is defined at distance over gallon. And we know the distance is the rate times gallon. And we know the how many gallon do we need is the distance divided by rate. Okay. So now if we say our car is actually 28 miles per gallon, then we have, say, 14 gallons in our tank. Then the distance we can go is the distance equals to 28, which is a rate times 14. So what's 28 times 14? 28 times 14. That will give us 392 miles. Yeah, we're good on this one.
Yeah.
Okay, perfect. Now, if you want to figure out gallon, if you say, okay, I need to drive, say, 370 miles, and I know it take me, uh, say, depends on what kind of car you have. Some cars is slower. Let's say only about 19 miles per gallon. So therefore, we know our number of gallon we need is distance 370 divided by that. So on this one, we pretty much just keep like this because we don't know where to which stage it can run the. Okay, are we good?
Yeah.
Okay, so I give you a couple to try it on. All right, we got um, so we know the rate is 25 miles per gallon. Then we got 13 gallons. So what's our distance that we can travel? Very good. Got 325 miles. So now instead of that, we know we have to go 1400 miles, and our mileage rate is, say, is 30 miles per gallon. So how many gallons do we need? All right, so we got 1400 over 30. We got that. So 140 divided by 3. So and we got 4, right? It's 12, 20. Okay. Oh, 25. No, it's 30 miles per gallon. That was the top. Sorry, the first question. I should erase that. That was the first question. Okay, that should do this one. Very good, very good. Okay. So now we are going to looking at some applications about linear equation. One applications is used in like similar triangles. And so basically similar triangle is that if you have one triangle like this, then you have another triangle. And if this angle and this angle are congruent, this angle and this angle are congruent, and this angle and that angle are congruent, then this is called similar triangle. And so basically one is, you can think this triangle is a scaled up version of this. This is triangle A, triangle B. So B is a scaled up version of A, or you can say A is a scaled down version of B. And the property is that the area, the ratio is the same. Like say this is our A, there is our capital A. Well, not your capital A. Let's use alpha. And this is our B, and this is our beta, and this is C. This is our gamma. So therefore, A over alpha. So the scale between this and that is the same as B over beta, right? Remember, we just scale up or scale down version. So the scale factor is the same. And all right as long as they are corresponding to each other. So we could C our gamma. Good. Yeah, it can.
Yeah.
All right. Or you can just give me a thumbs up. You can give me that emoji. Okay, so this actually turns out to be very useful using similar triangles. Now, this actually is more than 2,000 years ago. And the Greeks trying to figure out if if I see a boat like far away, how can I how do I know its distance to the shore? So you got a boat here. You got that. Okay. And so you got that. And you got the shorelines here. Let's see. So this is your shoreline. Okay. And maybe have some grass there. Okay. Then how do I know how far that boat is? So because the ancient Greeks are very good with geometry, so they figured out a way to do it is that, well, I can have some kind of either kind of in a there is some kind give me one. Okay, some kind of tower. Okay, if I have a tower like that, and they actually use a tool. It's kind of like, it can go like this. And this is half circle, and then they had markers on the angle. And so there is some kind you know, let's see, some kind of I'll just think of this as some kind of table. And so the people can just go, oh, run out space. Oh, let's see, this is a bigger. And the person just looking at this here. And he just using this one to adjust this and to find the point. Let's say we're trying to find point here, the top here. Okay, so they have to line up a little bit like this to line up. Okay. Yeah. And of course, there's going to have some angle between here and the perfectly. Let's say this angle is here. This is a perpendicular here. So now they got something, got the angle here. So you can see that we actually got triangle from here towards standing. Or actually it's more towards, yeah, from here to here. Yeah. And so he made a triangle, and then he turned this around and used that to look this way and then make another triangle. So basically what you can do is you can make a triangle like this. And you can also make another triangle like that. Good. Okay, this probably make more sense. Is going we look here, look down here. So that's how we can that distance. Okay, this is like look this way. Okay, so this is the distance here. And it'll make another triangle, just much shorter one. Now, we know that the height of a tower, and we know the angle. So therefore, we make a little triangle here, and this is angle. And therefore, we know something has to be in proportion. That means if the total here is h, and well, let's use the capital H, and shorter one here is just h. And now this, we call this small b, and this is b, which is the distance, the ship to the shore. So we know that h over, well, let's do the other way. The capital H over small h, that should equal to capital B E over square B. So of course, we know how high this one is, and we can measure this, basically some kind of table and the equipment. We know how high that is. So we know H, and we know capital H, we know the small lowercase h, we know the lowercase b, we just don't know what capital B is. So, but we have this equation now, set it up. So therefore, the B will equal to H over lowercase h, then times B. So if I say, okay, I know the whole tower is 12 feet. And this one here, the table here, maybe it just, let's make it a little bit higher. So the tower, let's say this tower is 100 feet. And this one may be just 4 feet. So h is 100, and little h is 4. And we can measure this. If we measure this one to be, say, 30 feet. And so we have the equation 100 over 4 equal to this capital B, this distance, and over 30. So we set this is called proportional. So therefore, we can multiply 30 on both sides, and that cancels. So we got B is 100 over 4 times 30, and that give us 25 and 30. and then 25 times 3, what we got there, 750 feet. So basically, without actually, we just cannot measure on the ocean, but using the property of similar triangles, now he's able to actually make a calculation about how far the boat is. Now, of course, in this is important when if there is enemy attack, so you can see how far the enemy ship is, and you can actually they can also, by measuring the distance at one time, then maybe 10 minutes later make another measurement, then they can actually estimate how fast the ship is coming, and then they can estimate how long it would take the enemy ship to get to shore, so that way they have time to get prepared. Good. All right. So I'm showing another example is when they're trying to measure let's say we have a lake and we want to measure the distance across the lake. Now we don't have any way, we don't have any, well, first of all, we don't have long enough like ropes or anything or rules. We we don't have any of that. Let's say we only have something called the yardstick, which basically allow us to measure up to 1 yard. And we know 1 yard is how many feet?
3.
3, yeah, 3 feet. Okay, so now what we have the yardstick. Now, how do we do the measurement? Well, we're going to use the idea of that. So we're going to put something here, maybe just 2. We got 2 stick, put on either side, and we are going to make 2 triangles. One is going from here to here. Let's say we can make a right triangle. And then we can continue this a little bit here, continue this a little bit here. Now, if we make sure we can make a parallel line between these 2. Now we got 2 similar triangles. This is a 90. Okay, now we got 2 similar triangles. So, and we don't know what this is. This is our X. Well, but we can measure though from here to here is a yardstick, because this is on the line on the ground. So let's say we measure is 100 yards. Then we have those 2 little triangles, and we measure this one is about, say, 20 yards. Oh, it's not drawing scale. And we also know this one is, let's say this is 50 yards. So now we know 3 numbers here versus here, and it's 50, 100. So we know that because it's right triangle, means similar triangles, so they are in proportion. So therefore 100 yards over this, because this is corresponding to this line, and this is corresponding to this line. So therefore over 20, that should be the same as X over 50. Now 100 over 20 just gives us 5. And so therefore X would be 5 times 50 is 250 yards. So therefore, without yards, without actually measuring anything, cross that, and they can just do that. And this is how they do surveying. Once they do survey, people using things, some kind of instrument, they're trying to make, measure distance. And a lot of times they can just use similar triangles and to figure out the actual length. Good?
Yeah.
Okay, and to give you one more example is how to measure the width of the river. So same thing, if you have a reference somewhere on that side, maybe a tree, and you find the reference here, and you're trying to those are kind of like perpendicular to that, to this way. So this is just water. And same thing, you can basically form a similar triangle. You can go do like this. And now we know this is a vertical angle that all congruent. Vertical angles are congruent. This is a right angle, so this is a right angle. So therefore, this angle will be congruent to this angle. So we got two similar triangles. Now, of course, we can measure from here to here. That's the easy one, right? Let's say 50 yards. Then we form another triangle. Then let's say this is 3 yards. And now we also know this because this is on the dry land. We can do the measurement. Maybe this is maybe say 100 yards. Okay. Now we want to know this distance, which is x, but we know they are they have the scale. So basically, the bigger one is the scale up the version of the smaller one. So therefore, if we look at the corresponding side, they should have the same scale factor. So we can look at 50 over this side, and that equal to basically will be x over 100. So therefore, x is 50 times 100 and over divided by 3. So 50,000 divided by 3, we got what? 1, 3, 2. So we got 666.6 bar. So we got 1,066, 6 and 6 bar yards. Good.
Yeah.
Yeah. So by using algebra, basically this is algebra, and also the property of similar triangles, and you'll be able to do those kind of things, and which seems impossible, but by using math, you actually can you can do those. You can calculate those. Just we don't have to actually measure it. We can just calculate it. All right. I'll see you next week. Good. Yeah, Eddie, we good? Hello, Eddie.
Hey, my laptop was shut down, so yeah,
Oh.
that's why.
Sorry, do you need to go back?
No, it's fine. It's fine now.
Okay. All right. I'll see you next week. Okay.
Okay. Bye,
Bye.
Dr. Ping.